So we're going to solve different types of trig equations using solving linear equations and also some factoring methods. So let's do a little review on just, again, looking at the trig ratios and figuring out what angles provide the same ratio. So for cosine theta equals root 2 over 2, we want to be in the interval 0 to 2 pi. So in order to get a better look at what triangle I'm using, root 2 over 2, if you don't know what that is, we can also rewrite that into 1 over root 2. That's before we rationalize the denominator. Adjacent is 1, root 2 is hypotenuse, so that should provide a 45-degree reference angle. So with that, I'm going to make sure I plot a 45-degree reference angle onto the correct quadrants. In order to find the correct quadrants, cosine is positive in the original problem. Therefore, I know that cosine, according to the All Students Take Calculus acronym, cosine will be positive in quadrants 1 and in quadrants 4. So I go ahead and plot my 45-degree reference angle onto quadrant 1 and quadrant 4 to kind of get a visual of what I need to do. 45-degree in quadrant 1 is fine as it is, so the reference angle itself should be 45. And I need to change it to radians because in the question, it did tell me to put it in an interval from 0 to 2 pi. Therefore, I know that the units that I want to put my answer in should be in radians as well. So 45 degrees in radian is pi over 4. And for quadrant 4, I do 360 minus 45 degrees equals 315, giving me a radian value of 7 pi over 4. Doing the same thing with tangent, I can see that I have negative root 2. So I'm going to change into a fraction so I can see what ratio I have. And the ratio is going to look like root 3 over 1, opposite over adjacent for tangent. So I'm going to draw a triangle, opposite and adjacent, and my reference angle for this is going to be 60 degrees. Tangent is negative in 2 quadrants, quadrants 2 and quadrant 4. Therefore, I'm going to plot my reference angle in those 2 quadrants to get a better look at my actual angles. So for quadrant 2, I'm going to do 180 minus 60, giving me 120. And 120 in radians will be 2 pi over 3. In quadrant 4, we're going to do 360 minus 60, giving me 300 degrees. And 300 degrees to radians would be 5 pi over 3. Just change that really quick. 5 pi 3. Okay. So I have my 2 answers, 2 pi over 3 and 5 pi over 3. All right, so with that review, let's do a little bit of algebra review. I want to make sure I know how to solve for a given variable with different methods. So if I'm just solving for an equation, seems pretty easy. I subtract 12, and then I divide by 5 to get my a value as 8/5. If I have a quadratic, I can take out a GCF if possible. And with my GCF out, I get 3a times the quantity of a plus 4. And with zero product property, I set each of my factors equal to 0, and a equals 0 and negative 4. In scenarios where I don't have a GCF and I just have to factor, I go ahead and factor that to get a minus 7 times a plus 2 equals 0. And I set each factor again equal to 0 to solve for my 2 values of a, 7 and negative 2. So we're going to use these methods to hopefully set up an equation so that I can have a ratio for a trig function, and I can set up my reference angle accordingly. All right. So for example 1, I want to solve for x in the interval from 0 to 2 pi. So again, my answers will be in radian. I have 2 sine x minus 1 equals 0. So at this point, I want to isolate sine of x so I can see which ratio I'm working with. So I add the 1 and I divide 2. So I get sine x equals 1/2. Okay, using my understanding of sine, I'm gonna plot it on the triangle opposite over adjacent, opposite over hypotenuse, and you should get a reference angle of 30 degrees. Again, just like my review, I know that sine is positive in a certain quadrants, so it's going to be in quadrants 2 and 1. With that knowledge, I'm going to plot my reference angles in quadrants 1 and 2. And that gives me a visual of what I need to do to get my actual angle. So to get the one in quadrant 1, I'm going to do, it's actually just 30, it's itself. So converting it to radians, that would be pi over 6. Quadrant 2, 180 minus 30 gives me 150. So that would be the degrees, but in radians, that would be 5 pi over 6. We're going to try the same thing with tangent. I'm going to solve for tangent x so that I get root 3 over 3. And changing it back to an easier fraction to plot on a triangle, I change it back to 1 over root 3. Opposite is 1, adjacent is root 3. Therefore, my reference angle is 30 degrees. Tangent is positive in quadrants 1 and 3. And this time, I'm not going to graph this on my coordinate plane. I want to see if I can kind of just visualize and have a better understanding of what operation I need to do to get my actual angle. So in quadrant 1 is already totally fine with the reference angle itself. So in quadrant 1, your angle is going to be 30, which means the radians will be root 6. And in quadrant 3, I know that in quadrant 3, I'm a little bit past 180. So I'm going to add 180 with my reference angle to get 210. So in quadrant 3, I'm always adding 180 and the reference angle. And the radian version will be 7 pi over 6. That's a little tip, a little practice that you want to try to get used to. Trying, not so much as graphing it, but just having an understanding of when you're in a specific quadrant, are you going to be adding or subtracting? Are you going to be using 180 or using 360? So that will take a little bit of practice to do. In this example, so this one is going to be a quadratic, and it might not look like it, but this is very similar to the algebra review we had in the front and the beginning of the notes. So it is similar to something like this, okay, where I have 2x squared minus root 3x equals 0. So I'm replacing my cosine x with the variable of x, and I can see it's more like a quadratic equation here, and I would take out a GCF of x. If I wanted to continue that, you can solve by setting x equal to 0 and 2x minus root 3 equals 0. So with that, we're going to do it with cosine in the problem. So I'm going to take out a GCF of cosine x, and I have now two factors. So I set each factor equal to 0. So the first one should be x, cosine of x equals to 0. And I know that cosine equals 0 in two places. They're in the quadrantals at 90 degrees and 270 degrees. Both of these in radian form would be pi over 2 and 3 pi over 2. So yeah, these are your quadrantal angles. Okay. The other one, I'm going to set 2 cosine x minus root 3 equal to 0. I solve for cosine to get my reference angle of 30 when I plot my sides. And I know that cosine is positive in quadrants 1 and 4. So I know that in quadrant 1, the reference angle is the appropriate angle of 30 degrees, which means in radian that would be pi over 6. In quadrant 4, I'm going to do 360 minus my reference angle to get 330 degrees, which is 11 pi over 6. So I have 4 angles within my interval of 0 to 2 pi. I have pi over 6, pi over 2, 3 pi over 2, and 11 pi over 6.